This month on the Interplanetary Podcast.
In the news in the month of May, the International Space Station, ExoMars, Hitomi Space Telescope, Vostochny Cosmodrome, Dragon Cargo Splashdown, Falcon 9 Landing, the Red Dragon, School Children, CubeSats and Meals, How a Rocket Works with space expert Jerry Stone, and all 7 major rocket launches in the month of May.
The Interplanetary Podcast. The exploration of space for the benefit of all mankind. Your hosts here in London, Matthew Russell and Jamie Franklin.
Welcome to the 3rd Interplanetary Podcast.
It feels like we only just started. How are we on 3?
I don't know how we're on 3, Jamie, but life whizzes by.
This is amazing. Welcome back, guys. Thanks for listening, as ever.
So, it's not rocket science.
Not.
So I've come up with a better one.
Here we go.
The Interplanetary Podcast, putting the ace back in space.
Holy moly. I'd like that to stay.
Okay,
but listeners, it's up to you. What do you think? Better or worse?
Yeah, vote yay or nay on that one. Yeah,
I like it.
I quite like it.
What's first up?
Out in the space world.
Yeah.
So, a monumental day for the International Space Station. It's completed its 100,000th orbit of Earth.
Wow.
On May the 16th.
100,000 orbits.
Yeah, it's done 100,000 orbits. And a couple of days before that, one crew member, I don't know which one, took the 3 millionth photo.
Wow.
And I have to say, this week, Tim Peake has been taking some ridiculous photos.
He's hitting them out of the park.
He is hitting them out of the park. There was that one photo of Britain with the cumulonimbus cloud coming out.
Yeah.
It was just unbelievable.
Yeah.
I think that might be my favourite photo.
And wasn't there some sand dunes in Iran?
And yeah, and about 2 hours later, he
Yeah.
took some sand dunes in Iran that looked like snake skin.
Yeah.
It was incredible.
Yeah,
that was absolutely amazing.
He's definitely got a career if all else fails.
Yeah,
Photography.
I was actually wondering what cameras they were, and then I saw a sort of rack of Nikon
That's
D4s hanging up, and of course Nikon is the one I use for my astrophotography.
Oh.
So I feel as though me and Tim have bonded.
Are you hoping to get some free equipment from this podcast?
Maybe Nikon.
Well, if there's anyone from Nikon listening...
Yeah, so Nikon maybe one of
other brands are available.
Yeah, I mean Canon are very good as well for...
Absolutely, yeah. We'd be happy with anything, to be honest.
To be honest, yeah. I mean, obviously Hasselblad is what they used on the moon.
That's very
true.
true.
There's still a couple of Hasselblads up there.
Really?
Yeah. In fact, there's a really nice Hasselblad on the moon, if you want to go and get it.
Well, yeah. Might be cheaper to buy one. So what, 100,000 orbits?
Yeah, 100,000 orbits.
That's quite an achievement.
It is. One sad one, though. The European and Russian ExoMars program that we talked about in the last podcast because of the successful launch. Unfortunately, they've decided to not go for the 2018 window for the second part, which is the rover, which they're sending.
Okay.
They're delaying that to the next Mars window, which is 2020.
Right.
And I just didn't think... I think they thought that they weren't going to be able to get up to speed in time, so they put it back, which is a little bit...
yeah, it's disappointing, but you can understand why.
It is pretty disappointing. Right at the beginning of May, even more disappointing for the Japanese, was the X-ray space telescope.
Yes.
Now this thing's called Hitomi, and it's an amazing looking satellite. The pictures of Hitomi, and I'll stick the pictures up on our podcast website. The pictures of Hitomi it looks like an amazing satellite, or was an amazing satellite. Unfortunately, this is a classic case of a software error.
Yes.
Software updates. Have you ever had that thing where your iPhone has asked you to do a software update and you deeply regret it afterwards?
Yes.
Yeah. Did it ever cost you 76 million?
I was going to say, this is a slightly more expensive mistake.
It is a ridiculously expensive mistake. So something to do with the software update meant that while the telescope was in space, it felt itself starting to spin. And so what it does is it starts up its reaction wheels. They do fine control of telescopes in space, basically.
Yeah.
But that made the spin worse because obviously the software was telling it one thing, and and it was doing the wrong thing to compensate. And this got worse, and so the rocket stabilisers then kicked in and made it even worse. Now all this is happening while the satellite's on the other side of the Earth to Japan, so the sort of control centre are kind of not being able to do much about this. And unfortunately, the thing span so violently that it's fallen apart.
Right.
Solar panels have come off and it's basically span into tiny pieces.
No one likes space junk.
No one likes space junk, so that's bad news as well. So there's so many of these satellites. I was reading another a thing about, our favourite, the Breeze M third stage. Where there's another one called the Block DM, I think it's called, or Block 40, one of the Block ones that goes on Proton rockets, and they tend to blow up in space. And I thought, that's pretty bad. And of course, they put debris absolutely everywhere. It turns out 45 of these things have blown up, and their debris absolutely everywhere. So it's they're sort of sitting in orbit, and then once the fuel corrodes through and then explodes with the other fuel in the other part of the rocket and splashes it all over into orbit, which is obviously bad news.
Explosions on Earth are bad, but in space,
well, the more you read about space debris, you can't quite believe how bad it must be up there. It is actually becoming like a super duper problem with space debris. So so the Japanese, it seems that on the initial look at this is that someone was cutting corners and it had led to this software mistake, and that's that. The end of their telescope, which must be absolutely heartbreaking.
That's very sad.
Well, it's really heartbreaking for the scientists who's maybe spent the last 15, 20 years developing it and getting it into space, and of course the astronomers that wanted to use it, the international community for the science that it was going to bring. So it's horrific.
Is there talk of them potentially doing another one? Or?
I would think that they will want. I mean, a lot of these things, it's quite hard to get money out of governments when you sort of go back to them and say, "Oh yeah, the last time you lent us loads of money to do this science experiment, and we
blew
managed
it up,
and we didn't deliver anything."
Yeah.
It's never a good look.
No.
So it's never a guarantee that they'll be able to replace this thing.
Well, I hope they get to.
Another very interesting thing happened this month, interesting for lots of ways, is the new Cosmodrome in Vostochny. Opened for business. So a Soyuz 2.1A rocket, just at the end of April, April the 28th, so after our last podcast, became the first rocket to lift off from the new and over-budget Vostochny Cosmodrome. Do you know what President Putin said when he arrived?
Oh, what's he said?
So it's over-budget because a lot of the people working on this thing have been totally corrupt and have been siphoning off money.
Right.
And the launch was a day late, so Putin was already in a bad mood, and then he has to get a hotel in Vostochny, which I can't imagine that they have particularly salubrious.
No.
So on the day of the launch, everyone is, of course, pale and ashen with Putin there going, if this doesn't take off, we are absolutely doomed.
Yeah.
But it already basically said that anyone found guilty of corruption, if their guilt is proven, he said, they will have to change their warm beds at home for plank beds in prison.
Oh.
So and I imagine it's a particularly stressful time for the Vostochny bosses.
He doesn't really dish out empty threats.
No, I think it's kind of...
Yeah.
There's a whole bunch of people...
If Cameron said that, you'd kind of shrug, wouldn't
you?
You
go, whatever, Cam.
Sure you will.
Well, yeah.
But Putin's another matter. Well, and how did it go?
Oh yeah, so the launch was successful. A day late,
goodness.
but successful. Yeah, so that's good. Elon Musk, of course, announced in late April that he would be sending a red dragon to Mars.
Yes.
That was, of course, caused an almighty sensation on Twitter, etc., etc. Mm-hmm. So obviously, I think in terms of Twitter traffic, that's probably the biggest news story of the month.
For sure.
Yeah. And I'm not quite sure what I think about it. Is it?
I was going to say, what are your thoughts?
My thoughts are, it's exciting and it engages the public.
Can you outline the bullet points of what he wants to achieve and how long it will take?
Well, I think he wants to prove his technologies. These landing on the barges, they've kind of sort of said it's not just about reusability of the rockets themselves. It's also working on technology for landing on Mars. So it's not just this all this technology is also the technology that's involved in what they're thinking of using to land on Mars.
Yeah.
In fact, someone made a very interesting point that also their sort of self-driving cars in Tesla, maybe some of the software has found its way into that as well.
Oh my goodness!
Yeah,
okay.
which would be quite exciting.
Yeah,
you know.
For real. He's a clever sausage.
Clever sausage. But yeah, I mean, it's I'm still not quite convinced about of going to Mars just yet. It's super ambitious. There's no two ways about it. And of course, it does revolve around the fact that he needs to get Dragon Heavy going, which he still hasn't done. So maybe he will miss that 2018 launch window.
It's hard to imagine that there won't be any mistakes on the first attempt. As well, isn't it?
It has to be said. It will be phenomenal if he lands a Dragon module that's capable of carrying humans on Mars.
Yeah, what's the
in
implications
2 years'
of that?
time?
Yeah,
it just seems. I just think it's almost too incredible to believe, especially considering just how far away NASA are from doing it. They're only just going to be trying out their SLS.
Keep
in
up,
2 years'
NASA.
time. Yeah, of course, NASA. Of course, another thing is NASA. Of course, stumping up the cash for Elon to do all these crazy, possibly ego-driven manoeuvres. So we've got to look out for that.
Also, in the news this week, I think I told you about this. He said that there's a distinct possibility that we're all being controlled as simulation computer games. From a more intelligent.
I must admit, this one's been going round for years and years and years. Ever since the Matrix is based on that whole.
Yeah.
In fact, it's
virtual reality is as good as it is now.
I think it's a 19th century idea. This whole thing of simulations, but yeah, I mean, if mathematically it makes sense. If there are such things as simulations that are convincing, and you run, and obviously you'd want to run them, the likelihoods of being real is less than the likelihoods of being a simulation.
If any of my simulators are listening, could they possibly make me a bit taller? Because I mean, surely that's easy to program, isn't it?
No, they ran out of RAM for you.
Yeah.
Which they ran out of RAM for a goat farm out in.
Good.
Thanks.
Good.
Right, moving on.
on.
So what else happened in the news? Have you seen the X-37B? It's a robotic space plane that looks kind of like a mini space shuttle.
Can't say I have.
It's quite. I'll show you a picture.
Okay, we need to look this up.
Right. So when you have a look on the notes of the show, which I'll post up on the interplanetary.org.uk.
Nice.
It'll be on there, and basically, the X-37B is an interesting military plane that's highly secretive. No one really knows what it is, but it's been flying around up in space for. It finished a year orbit during May, so it's been up there for a year, just flying around.
Will we ever get to know, or is this classified?
Well, it's classified information, but then so all the space planes, rocket planes, have always been classified because they're finding out, sensitive information. Well, it's not necessarily intelligence, but how things work in space and ultrasonic speeds, etc., etc. So it's science, but science that the military want to keep for themselves for the time being, because they're paying for it after all. SpaceX, one of the cargo missions that made it to the ISS, also came back down and was successfully came back down to Earth and splashed in the ocean, and all the science recovered from it.
Nice.
And Tim Peake said a lovely thing as he looked out the window, and he said, "Dragon spacecraft has served us well, and it's good to see it departing full of science, and we wish it a safe recovery back to planet Earth."
Ah.
So it must be quite nice looking out the window and watching this thing.
Yeah. Bon voyage.
This space.
He hasn't got long left, Tim, has he?
No, he hasn't got long left. He had it a little bit extended, didn't he, his stay?
He's just had his suit fitted again and testing his seat.
Yeah, he's been a lot of he's tweeted a lot of space rocks, and a lot of the songs are about how he's coming home.
Yeah,
which is quite nice.
Yes, it's gone quickly.
Yeah, it has gone very quickly, hasn't it? On the 16th of May, and this is a really cool story, I think, is the International Space Station released something called the STM-SAT-1, which was a 3-year-long project that involved 400 students from sort of little school, little kids, right up to high school kids, and they basically were involved in making a CubeSats, and that was released from the International Space Station. So
nice.
It's an actual sort of satellite built by school children, essentially,
That's
which I think was a really cool idea. And in the same time, this month, the astronauts ate a meal that was also kind of prepared by the students.
Do we know what they ate?
Yes, it was a Jamaican rice and beans with coconut milk.
It's the kind of thing I like.
Yeah, and imagine that would be quite a kind of cool thing to have.
You can't have that every day on the ISS.
No, so both both those projects were schools from Virginia.
I think it's awesome how much schools are getting involved with social media and what's happening on the space station, and how interactive people like Tim Peake are. It's fantastic.
Yeah, I mean, there's a lot of criticism about the International Space Station, just how expensive it is. But when they do things like that, and it does engage, I mean, Tim Peake has undoubtedly made a huge contribution to science purely by engaging children and kind of making them maybe create the next bunch of space scientists.
Absolutely.
And he said a beautiful thing about how the teachers were really, really important and what a great job they were doing. And I thought, good on you, Tim, because not many people stick up for teachers, but he was totally on their side. Good on you.
God bless the teachers.
I tell you what, why haven't we talked about this yet? And that is the Bigelow. The Bigelow expandable activity module that we did talk about. It's finally got to inflate. Now, I did mention last time that it wasn't an inflatable, but it was in actual fact an expandable. But it turns out I'm slightly wrong about that. And it's a bit of a kind of...
Good for you for admitting that.
Well, yes, Matt. You know, and and that's why NASA, someone who works at NASA, had kind of pointed this out on Twitter, that actually, no, these things are... This one actually is inflatable. Yeah. It's considered inflatable. There's a very kind of thin definition between the two, inflatable and expandable, but this is an inflatable, and they managed to inflate it right at the end of May, and only a couple of days ago the astronauts started going in there and doing some tests.
Nice.
So that's a really exciting... It's actually more exciting than it sounds, an inflatable habitat, because if this technology is proven, it does make sending larger objects to space more feasible.
Quite easy.
It makes it a lot easier, and then using them as habitats on the moon and on Mars.
I've got a question though.
Yeah.
What happens if a bit of space debris whacks the inflatable?
Well, I mean, this is obviously one of the things that it's got to prove, that it's able to cope
durable,
with. Yeah. That it's not, doesn't pop like a balloon.
I'm a little worried about that. Yeah.
Well, yeah. I'm sure. I mean, like everything that has to go into.
We all know what happened in the film The Martian.
Yes, that's exactly right. In the book, it's really brilliant, that bit where it starts with the journey of the seam being made in the factory, and how that seam then wasn't quite right, and by the time it gets to Mars, it just doesn't last as long as it's supposed to.
Yeah,
just because of the way that it was sewn at the factory back in.
And it blew up his potatoes.
It's really it's quite bad.
That is a spoiler alert. Sorry.
Actually, if you haven't seen The Martian, go see it. That's only a small bit.
Yeah.
Well, we haven't really said anything.
I think we've sold it, if anything.
Yeah, if anything, we've
exploding potatoes in space.
So yeah, if
the
makers of The Martian could maybe sponsor this show.
So that's Nikon and Warner Brothers.
So let's have a quick look at what went up in the month of May. So the very first launch of May was on May the 6th. This was a Falcon 9. Which was, of course, it was a SpaceX. A SpaceX mission, and it was carrying a satellite called the JC-SAT.
Nice.
It flew up from Cape Canaveral, but it's, of course, the big news about it was that it managed to land the booster stage back on the barge Of Course I Still Love You.
Yes.
A repeat of the astonishing achievement that it had achieved with the CRS space station mission about 2 weeks before. But this one, I have to say, is even more remarkable because it had to go a lot higher. So the space station is actually quite low. It's only 250 miles or thereabouts.
Yeah.
So this one, it was actually quite low, but this one had to go quite a bit higher because it was launching it into a different type of orbit. And because of that, the first stage is coming down at a ridiculously high velocity. Yes. And this is, it's just brilliant. So as it came down, it used 3 engines instead of the normal 1 to slow itself down onto the barge.
Yeah.
Which is significant because it just shows how much they've nailed that technology. There's a real big difference about using 1 engine to slow yourself down and using 3 engines to slow yourself down. That whole thing about to relight them and use them in that way is quite an astonishing achievement. And of course Elon Musk couldn't help but brag and his now famous line, may need to increase the size of the rocket storage hangar, is now his sort of is one that keeps...
Can I just check, was that his accent?
No, his accent is actually, may need to increase size of rocket storage hangar, because he's of course city Falcon.
I'm worried we're verging on the racist here.
No, well...
Apologies to any South Africans listening.
I think a lot of South Africans will say that's a very good impression.
They might say.
Maybe a little bit District 9. A bit later on May the 15th, the Chinese were in action with their Long March 2D.
Yes.
So Long March, the Long March series of rockets are of course the Chinese mainstay of rocketry.
Yes.
And this was Long March 2, and it launched a military spy satellite, so no one really knows what it was. And on May the 23rd, their neighbours and rivals, the Indians, were in action. And they've got themselves what really looks like a sort of mini space shuttle, but it's a different kind of technology, really. But it was a test thing. It was only a little scaled down version of what they eventually hope to achieve.
Yeah.
So this thing is called the RLVTD. That was a really nice one to watch the launch on, the video of the launch.
Absolutely.
Was really
good on you, India.
Now, a really exciting one. Now, the Europeans were then in action because we are on May the 24th. A Soyuz, and it's a sort of Europeanized Soyuz, they call them. Launched Galileo 13 and 14. So it launched 2 satellites, and they were sort of side by side inside the payload fairing.
Interesting.
Yeah, it was really interesting. So that's quite a chunky thing. And Galileo is the European GPS system. So obviously that's satellites 13 and 14. Galileo.
I'm so sorry.
No, that was good.
I had it in my head and it just needed to come out.
Yeah, no, we can't really let Freddie references go by.
Is that the joke, please?
Yeah, on their way.
Yeah.
No, it's the end of that Sheer Heart Attack track.
Oh, yeah.
So that's obviously satellites 13 and 14 of the Galileo. I don't know how many they're going to send up, but it's a hell of a lot more than that. So eventually there's going to be a whole heap of them because you need a lot up there to do a proper GPS system. So that's going to be a lot of the Russians have their own system, the Chinese are putting up their own system, and the Indians are putting up their own system. So the European system is the Galileo, and that went up on May the 24th. A surprising lack of coverage on that one.
Yeah.
Considering it was a European one. But again, I watched the video of the launch, and that was really cool.
Awesome.
As well. And then on next day, after that, another Falcon 9 went up.
Another
with
one.
Thycom 8. And again, managed to get a first stage back down onto the barge.
Successful
now,
barge landing.
I'll tell you what's a brilliant video is the video of on the booster itself as it comes back down through the clouds onto the barge.
Yeah, I've seen it.
That is phenomenal.
Yeah.
It's literally, that is just brilliant, particularly when you remember just how big these things are.
Yeah, of course.
It's just like, wow.
If you're going to stick a GoPro on anything,
it's brilliant.
That's not bad, is it?
It's not bad, is it? It is genius. The fact that it just sort of knows where the barge is.
Yeah.
They don't talk to each other. Just you're probably going to be there.
Yeah.
Bang, there you go. Straight in the middle of the SpaceX logo.
That's great.
Yeah, SpaceX marks the spot. And a couple of days later, we had another Soyuz carrying the GLONASS-M satellite, which is a global navigation satellite system, the Russian one, part of the Aerospace Defense Forces.
Nice.
So, and that took off from Plesetsk on May 29th, and the very last launch of May was a Long March 4B. So the Chinese back in action.
Yeah.
And it launched a couple of satellites, NewSat 1 and NewSat 2, which are high-resolution Earth observation microsatellites.
Rolls off the tongue.
Yeah. So, and it also launched Sijuan 3, which is a Chinese satellite. So that was the launches for that.
Been a lot going on.
There was a lot going on that month, but not as much as there seems to have been in June. But we'll talk about June in a couple of weeks' time.
We will, yes.
We must apologise to the listeners. We have been very late with this podcast, and one of the reasons is because both Jamie and I have been very busy human beings.
We have been all over the shop.
Yeah, there's not just space going on in the world. There's also life.
But hey, we're back.
We're back for you guys. So the legend that we want to talk about this month is a lady called Yvonne Brill. And I think this is really what she achieved in rocket science is actually quite phenomenal. So she, on any kind of level, would be considered a legend in her field. And in 2011, Barack Obama himself gave her a medal for her services.
Yeah,
to the,
rightly so.
Yeah, she died quite recently in 2013. And it was it's something I spotted, and I thought she's such a brilliant story. She's really famous as a rocket scientist because she designed a type of rocket engine that is used still today in most sort of a lot of satellites for manoeuvring into their correct orbits. It's a very kind of brilliant method of doing it.
Didn't she simplify it so that it became more controllable?
Yeah, I mean,
powerful.
Yeah, well, I think a real strong point is chemistry. That's what she was really good at. So she was the only one of her siblings that went to university. But what she really wanted to study was engineering.
Yes, and they didn't let her, of course.
No, and it was obviously in an era where they just thought, well, why would you want to do engineering? She was really good at physics and chemistry at school. But none of the teachers wanted to really encourage it because they thought, well, what's the point of a woman being good at these subjects?
So they pointed her in the direction of mathematics and chemistry, was it?
Yeah, so maths and chemistry, they could see that that there was some future for women in those subjects.
Yeah.
So when she went to university, that's what she studied, maths and chemistry instead of engineering. So she became very good at maths, and then she went to work for Douglas Aircraft in 1945, and she worked on a project called RAND. Now RAND was a secret, top secret at the time, military project, and it was a sort of low Earth orbit satellite, and it was used. Is it scramjet technology? Used. Oh no. Yeah, I'm going to go with Scram. Used Scram technology.
Okay.
But she got a little bit fed up of using. All she really did was doing a lot of the kind of grunt computer work, the slide rules and things like that for her bosses. But because she lacked the kind of confidence in maths and physics because of this, because of the way that society was, that she thought, I'm going to really concentrate on chemistry. So she joined the chemical group, which is really, really a fantastic thing for us, because with her kind of combined skills of being able to make these really hard mathematical calculations and her good chemistry, she was really, really handy at these ramjets. It's actually ramjets that she's really good at. And so she ended up working for a smaller company just at the point where Rand were sort of saying that these ramjets were never going to work. But the smaller company was starting to nail it. So yeah, she was really good at that. And then she met her husband while she was studying at the University of Southern California. But she used to go down to the library at UCLA because it was nearer.
Yeah.
And that's where she met her future husband, who said he was working on nut calibration, which was something to do with how much money you put in the machine to a ratio of how many nuts you got out.
Okay.
So she thought that was quite funny and cute, and or whatever. And Paul probably didn't think it was that funny, but they ended up getting married and they had children, which she then devoted a lot of time to, which I was going to lead on to another part of this story. And then she went to work for RCA Laboratories. Now, RCA, funnily enough, you see quite a lot on things like jack leads and things like that, and it is actually the same company. Yeah, they came up with a lot of kind of things from the audio industry. But she was a chemical engineer, a chemical electrical engineer, and that's where she designed her most famous invention, the hydrazine resistojet.
There we go.
Sometimes known as EHT. And that basically uses a small electrical current to heat up a normally non-volatile gas, and then that forces it out of kind of rocket speeds, and you're able to use that as a type of rocket, which is what has been used in a lot.
So essentially, she designed technology that enabled missions to go on for longer.
Yeah, well, missions to happen. I mean, it's an enabling technology that she's developed.
Wow.
And I guess she's just a brilliant person.
Hats off.
Yeah, hats off to her. She was a very, very clever woman.
She literally was brill.
And then in 1980, when she went to work for NASA, and she worked on quite a few things like Tyros, which I think was one of the very first weather satellites. She worked on Mars Observer, and she also helped design the space shuttle engines themselves, which are now going on to the SLS. So it's her legacy is quite far-reaching.
And it was ever so slightly tarnished by
this kind of
Times.
Sexism thing kind of runs through this story from beginning to end, because when she died, the New York Times famously, in fact, it actually became more of a story, the New York Times obituary, than the obituary itself.
Yeah.
Because I think the New York Times excuse for doing a kind of sexist obituary was the fact that a lot of people moan when they see successful women and say, oh, they've sacrificed their home life and their family life, and these are dreadful people, we shouldn't be.
They're saying they wanted to highlight that.
So they thought that it would be good to say, no, this woman didn't sacrifice her family life. She was also an amazing mother and housewife, etc., etc. But of course, they've gone the wrong way, and it's one of those you can't win.
Yeah.
But I think it's an interesting thing, but I don't want to dwell on it too much because it's outside of rocket science, and it starts to become a little bit.
We don't be too negative.
But I mean, it detracts from the fact that Yvonne Brill.
But they quickly changed it and took it down.
Yeah. So Yvonne Brill was a fantastic woman.
She was
brilliant and long-lasting.
If you don't know about her, look her up, pay a bit of respect.
Yeah, and there's some brilliant interviews. There's a brilliant interview that she did that you can download the PDF with, I think it was the Women's Engineering Institute. Yes. And there's also a video on YouTube of an interview with her.
Awesome.
So that's actually well worth looking at because she's a remarkable woman.
So what else is coming up on the podcast, Matt?
So also on this month's podcast, we're going to have an interview.
First interview?
With our first interview with a space expert.
From where?
From the British Interplanetary Society.
OMG.
Yep, and he'll be telling us, which is an answer to a reader's question of what is a rocket.
There we go.
I'm very excited about this because the last time Jerry did this, it was on Blue Peter. So he knows his onions.
We've got a lot to live up to.
We have got a lot to live up to.
Now, Matt, you were talking about a reader question there. If any readers Sorry, listeners.
Listeners.
Even.
Did I say read a question?
Oh, it was probably me. But if any listeners have another question, how can they find out more about us and get in touch?
Well, you can get in touch via the website, and the website is interplanetary.org.uk.
There's also a Facebook page, isn't there?
There's a Facebook page, but if you go to www.interplanetary.org.uk, there's all the links to our Tumblr, which is our blog, and we've got our Twitter feed, and we also have a Facebook page,
there
like
we
you
go.
said. And what else?
Well, all the links are up there on that website anyway.
Yeah.
So we'll be putting photos up of the rockets Matt was discussing today, and we'll also be taking any questions for the next podcast, number 4.
Yeah.
Check it out.
And just as the British Interplanetary Society news, the 15th of June there's a talk on reusable spacecraft.
There we go.
And on the 22nd of June is a talk on Lunar 1.
And how can people go to that if they want to?
Well, you can go to it as a guest of a member, or you can buy tickets on the British Interplanetary Society website, or you can join the British Interplanetary Society and go for free.
There we go. What's
and
the website?
Well, the website is bis-space.com.
There we go. That website again?
BIS, putting the ace back in space. bis-space.com.
Perfectly read.
Yeah, thanks.
And now for our interview with Fellow of the British Interplanetary Society, freelance presenter on astronomy and space exploration, Jerry Stone.
Hello, Jerry.
Hi, Matthew.
How are you?
Okay.
Good.
You?
Very good. Thanks very much. Yeah. I've been on the tube much longer than I wanted to today. It's been absolutely horrific. Thanks very much for doing this. By the way, this is brilliant. Maybe we can do it live in the BIS library or something like that.
Now that would be something, wouldn't it?
Yeah, that would be. I think it's certainly slightly more salubrious than Skype somehow.
Yes, if it's good enough for BBC Worldwide, then
if it's good enough for them, it's good enough for us. We had a listener that asked how a rocket engine worked, and I thought, well, that's quite a good one for a starter.
there's 3 main parts to the rocket. The payload, what it's all about, what you actually want to put into space, and the rest of it is how you get it there, and that's in 2 parts: the engines and the fuel tanks.
Give us a little bit of info on how. I think really, the question I guess is about the rocket engine itself. I mean, my understanding is it's got something to do with Newton's second and third law, but
Yes.
if you can.
All rockets trace their history back to Sir Isaac Newton, the great British scientist, who told us, amongst other things, that every action has an equal and opposite reaction. And in the case of a rocket, it's the action of the burnt fuel creating gas shooting out the back of the rocket that drives the rocket in the opposite direction. So a rocket is basically in 3 parts. There's the payload, the thing that you actually want to put into space, and behind that is the actual rocket itself, which has 2 main sections. The important thing is the rocket engine, and there's also the fuel that powers the engine. Now, the fuel will either be solid fuel, like a November the 5th firework, or it'll be liquid fuel. On the space shuttle, they actually used both. They had a big liquid fuel tank which fed the engines on the space shuttle orbiter, and 2 solid fuel boosters on each side. But the simpler arrangement is just that you have a liquid fueled engine, or quite often more than 1 engine together. And the engine is fed from 2 tanks. 1 tank is the main fuel, and the other will be an oxidizer. because things burn much better when they're supplied with oxygen. And the same thing applies with a rocket engine. So there'll be some fuel which in many rockets is actually liquid hydrogen, and the oxidizer is liquid oxygen. So these two liquids are pumped into the rocket engine where they are ignited together, and it's basically a controlled explosion. So instead of instantly burning all at once, it's burned over a period of time, just like when you burn petrol in your car. And the burning of these two propellants makes them turn into gas, and something as a gas will take up more room than it will as a solid or a liquid. So it will try to expand, and to do that it has to expand out of the back of the rocket engine nozzle, and it's that gas flying out at really high speeds that sends the rocket in the other direction.
So that's presumably related to the force equals mass times acceleration bit.
Yes. So firstly, the rocket engine is producing a force. So knowing that force and knowing the mass of the rocket itself, you can calculate the acceleration. But as the fuel is being used up, the mass is actually decreasing. And if the force remains the same, but the mass is decreasing, then it means the acceleration increases.
Mm-hmm.
And in fact, on the Saturn V rocket, which took the Apollo astronauts to the moon, the first stage, they cut out the centre of the 5 engines after a while because the acceleration was increasing, and they didn't want that to get too high for the astronauts to endure. So by cutting out one of the 5 engines, that reduced the acceleration slightly.
Mm-hmm.
So that's why that engine stopped firing before the others.
And of course, I suppose an added element to that is as you get higher up through the atmosphere, you're getting less resistance. So presumably your acceleration increases because of that as well.
That's also true. And also because there's less air pressure, the plume of the exhaust will expand. It'll get wider. And you could definitely see that with the Saturn V, that it started off almost a narrow plume. And as the rocket got higher and higher, that got wider and wider, and you could see it expanding. It's quite dramatic. Now, as it happens, 2016 is the 90th anniversary of the launching of the world's first liquid-fueled rocket, and that was carried out by an American named Robert Goddard on March the 16th, 1926. He designed the rocket himself, he built it himself, and took it out to a farm belonging to his Aunt Effie in Massachusetts. And although it was a very short flight, it only lasted a few seconds, but the rocket travelled 184 feet. That's about 50% greater than the distance travelled by the Wright brothers on their first flight. So it's
not bad.
It's quite reasonable. And Goddard is known as the father of modern rocketry. And I've been giving various presentations of a talk that I produced for this year, which is called Nell, Esther and Aunt Effie. So Nell was the name of the rocket. Esther was the name of his wife, who took all the famous photos and also filmed a lot of his work, and was later recognised as the first person to be a documenter of space activities. And Aunt Effie, as I've said, was his relation. She wasn't actually a direct aunt, but a slightly more distant relation. But she owns the farm where the flight took place, with the rocket allegedly coming down in her cabbage patch.
So I'm assuming that the Goddard Centre and all the Goddard references at NASA are named after said Goddard.
Right. Early on, the US government were completely indifferent to Goddard's work. They really weren't interested, even when he went to them and offered help. And also the newspapers were pretty appalling. Firstly, they couldn't understand his work, even though he explained it very clearly. But they assumed that they knew better than he did. And a prime example of that was the New York Times, who wrote an article saying that he should know that a rocket needs something better than a vacuum to push against. Whereas, of course, a rocket works best in a vacuum because there's no air resistance to slow it down, and it doesn't need anything at all to push against.
Yeah, well, I mean, presumably that's the main advantage of a rocket engine over, say, a normal aircraft engine, for example.
And yes, and that's exactly why we use rockets and why we need to use rockets to get to space, because jet engines and propellers all work by pushing air back behind the vehicle, and there is no air in space, so they won't work there.
Yeah. I mean, with the aircraft engine, is there a form where you could have an aircraft engine that was air breathing, and then it would swap to a rocket form as it got to higher altitudes for so that you could actually use it as a spacecraft? Because obviously, one thing that I've always think people in their minds think, well, obviously, if you just carry on flying a jumbo jet and just keep going, eventually it'll end up in space. But of course, we know that's not true. But why isn't it true?
So Virgin Galactic are partly on the way to this with their Spaceship One, which became the first privately built spacecraft to fly more than twice within 10 days and won the X Prize back in 2004. That was a two-stage vehicle. There's an air-breathing, jet-powered carrier aircraft which carried the spacecraft up to a given height. Then the spacecraft was released and fired its solid fuel engine to go up and reach space. However, it would be more efficient if you could have one engine that could carry out both functions. And there isn't one that exists yet, but it's being worked on. There is one being developed. It's called Sabre, and it's the brainchild of Alan Bond, who was one of the men behind HOTOL, the vehicle which unfortunately was cancelled by the UK government. But this is an engine that's going to power a new vehicle called Skylon, and this is a British development. And what the Sabre engine will do is it will power this spaceplane, so it'll take off on a runway, and the engines will be fed by onboard fuel, but also they'll be taking in air at the front and blasting it at high speed out the back, so that's providing the initial thrust. But once it reaches about Mach 5, then the front of the engines are encased, and a nozzle closes over the front of those, and it then relies purely on the onboard liquid oxygen and hydrogen, and the engines work as rocket engines. So they provide both functions. They act as air-breathing engines and as rocket engines. And by doing it in this way, you don't have to carry all of the fuel that you need on board to start with, because you're using the air. It takes in the air and chills it down to round zero in 1/100th of a second, and that is amazing technology, and that has already been proven. It's been tested and it all works. So Skylon should be able to carry about 15 tons up to orbit, release the payload, a satellite or whatever it is, and then close its payload doors, re-enter the atmosphere, come back to Earth and land on a runway. And then after whatever maintenance is needed and refueling, it should be ready to fly in about 2 days.
Now that, I mean, when I obviously that it's an incredible machine, the Skylon, and it's a really exciting prospect for particularly the UK, because it feels like it's a homegrown project. And I remember the HOTOL really well as a child and being very excited about it. But in terms of going up against, say, Elon Musk's SpaceX, where he seems to be really ahead of the game and being able to get these first stages back down undamaged, what's the advantage of the Skylon model over the SpaceX model?
Well, the rocket engines that SpaceX is using are obviously not as complicated as the Sabre engine, so they'll be cheaper to produce. And certainly Elon Musk and the SpaceX team deserve huge congratulations for their work on recovering the first stages. That is also going to bring down their launch cost, because if you don't have to throw away the launch vehicle every time, then gosh, that's going to be so much cheaper. But an advantage of Skylon is that it'll have this payload bay, and you can put all kinds of different things into that, including a crew compartment. Skylon, I should mention, is designed not to need pilots, though there are options to have pilots on board in other versions later on. But its main work initially is being seen as effectively a satellite launcher. So there will be probably less maintenance needed between flights on Skylon than there would be on the Falcon 9, because you've got to check over the engines, make sure that they're working. I mean, they had to do this with the space shuttle as well. No space shuttle ever landed and was then hoisted up against a tank with boosters and taken out and launched again. They removed all 3 engines and checked them over, and it wasn't necessarily those same 3 that went back on it for its next flight. And it was really the cost of the maintenance and the checking of work on the engines and other parts that made the cost of launching the shuttles so high.
Yeah, I mean, I sometimes get the feeling that the space shuttle has given space planes, winged rockets, as it were, a kind of bad name because of the sheer cost. It ended up costing a lot more than they thought it would.
Well, yes. Now, one of the original proposals was that both the launcher and the orbiter would be vehicles that would come back to land on a runway and be used again. So the whole system would be completely reusable. The problem was that this meant the launcher vehicle would be much more expensive to develop, and it was decided against that, which is okay in the short term, but for long term, when you want to do hundreds of launches, it's obviously more expensive that way. The solid rocket boosters were always recovered, well, apart from one flight where they got lost at sea. But the external tank was lost every time, and so that had to be paid for, although they did do everything they could to reduce the costs. For example, the fuel pumps that transferred the fuel from the tank to the orbiter were actually placed on the orbiter, so they were sort of sucking the fuel out of the fuel tank.
How do they pump that much fuel into the rocket? How does that pump work? presumably that's a really important part of the engine.
Yes. I mean, they have turbo pumps on them, which can be incredibly powerful. For example, on the Saturn V, the F1 engines burned 2 tons of fuel every second, and that's for each engine. And that's pretty staggering. So those pumps, it was stated, were powerful enough to drain an Olympic-sized swimming pool in 12 seconds.
That's incredible, isn't it?
Yeah.
Of course, a really good engine that I was quite disappointed didn't take off yesterday was the 3 that were on the bottom of the Delta IV Heavy. I would assume I've seen them in just standing on their own with someone stood next to them, and they're much bigger than I thought they were. I mean,
they're huge, aren't they?
Oh, it's just they're just incredible. So yeah, I'm quite looking forward to when that actually takes off and watching it. I still haven't got round to seeing an actual being there in the flesh rocket launch. But
you need to make sure that you do that.
Yeah, absolutely.
There is absolutely no comparison between seeing a rocket take off on TV and being there in person. On TV, usually they zoom in on the rocket itself and follow it up, whereas when you are there, you actually see it moving away from the ground, and you really get the impression that it's flying. The other thing is, on TV, they have microphones close up to the launch pad. Now, at the space shuttle launch pads, which previously used for Apollo, nobody apart from the rescue team is closer than 3.5 miles. And at that distance, it takes about 15 seconds for the sound of the engines to reach you.
Wow.
So the engines light up, so about 5 seconds before liftoff. So the engines reach full thrust, they are burning, and then the rocket takes off and it's cleared the tower, and it's not until then that the sound of the engines reaches you. All you've got before then is the sound of people cheering and clapping and clicking and whirring of cameras, and then suddenly you get this wall of sounds that hits you, and you can feel your stomach vibrate.
Yeah.
It's a really incredible experience.
Well, I know with the shuttle that the noise at the actual on the launch pad was so intense that they have to water it down to stop it from vibrating the orbiter to pieces.
Yeah, the great clouds that you see coming out each side of the launch pad are not smoke, or they are not exhaust from the engines. That is water that's being turned into steam by the heat of the exhaust. And these thousands and thousands of gallons are dumped down. It's not just to keep the pad cool, but to cut down the acoustic energy that's created by the noise of the engines. And if that wasn't done, yes, it would literally vibrate the vehicle apart.
Yeah, I mean, for that as an acoustician myself, I know that acoustic energy is something that's normally quite an irritating low energy source,
Yes.
and like trying to get anything out of any is quite difficult because it's normally such a low energy. But it's incredible, isn't it, that it's got to such a high energy at that point that it's dangerous to a spacecraft. And how do they stop the? Presumably, as the gas comes out, the hotter it is, the more acceleration it has. So, how do they stop the nozzle of the engine itself melting?
Well, that's a very good question, because this is burning at very high temperatures indeed. And the usual way to do this is to circulate either fuel from the rocket itself or liquid from the turbo pumps around the engine nozzle. So it isn't a solid nozzle, but it's hollow, and there's tubing around that, and they pump this liquid around it. And if they do that with the rocket fuel and something like liquid oxygen, liquid hydrogen, they're very, very cold indeed. So that will help to keep the engine nozzle cool.
Well, yeah, and but I mean that's an ingenious way of cooling it down. Is there any rocket scientist who is kind of considered the inventor of that particular technique? Because it seems like a very novel and a neat solution to the problem.
So the idea of regenerative cooling was put forward by Carl Siemens in 1857, and it was first demonstrated by James Dewar of the Dewar flask fame on the 10th of May 1898, when he was able to liquefy hydrogen. And the idea was mentioned by the grandfather of space travel, Konstantin Tsiolkovsky, back in 1903. But the first regeneratively cooled engine was built by Robert Goddard in 1923. But at the time, he rejected the use of that because, having gone through the construction, he decided it was too complex. But he did come back to use it on his later rockets.
Wow. Yeah, it's interesting that that's a 19th century invention. I'd never have thought that.
It's 19th century in its concept.
In its concept, yeah.
Yes.
But yeah, good old Goddard again, then. The modern rocket engine doesn't seem to have changed much particularly since the Saturn days. Is there any kind of future development that's always kind of hung there but not seem to have gone anywhere? Because they do. It seems that the engines, say on the Delta IV, are very similar to the engines on the Saturn V.
Yes, basically it's just a question of what materials you use, what fuel you use to get the desired thrust. And there's different ways of doing it. So the Soviet N-1 rocket, which was intended to land cosmonauts on the moon, unfortunately failed on its 3 test flights, and all 3 rockets were destroyed in flight. And part of the problem there was the complexity of its rocket system. They were unable to build large, powerful rocket engines. So in order to get the total thrust, they had lots of smaller engines, and there were over 30 on the first stage, arranged in a huge circle, with software that, if it detected a malfunction in one engine, it would cut that engine out, and also cut out the engine on the opposite side, so the thrust would be balanced. But no, they just couldn't get the thing to work. Now the Saturn V first stage, its 5 F1 engines together generated 7.5 million pounds of thrust, so 1.5 million pounds each. And together they produced 180 million horsepower, which was more powerful than all the cars in Britain put together at the time. Well, that used a fuel called RP1, which was a form of kerosene. And RP1 basically being rocket propellant number 1. And this was essentially, it was a variation on paraffin, which led to the line at the time, for those who remember the other product, that America went to the moon on SO Blue.
Oh, wow.
But the upper stages of the Saturn V, the second and third stage, used an engine called the J2. 5 of them in the second stage, 1 of them in the third stage. And these were powered by liquid oxygen and liquid hydrogen, which is a much more effective, a much more powerful mix and can provide greater efficiency as well. So, in fact, one of the effects of that is because they burn together so efficiently, they don't produce a visible flame. So the famous films that were taken from on board the Saturn V on its test flights, looking backwards, you could see the first stage detach and fall away, and you could see the interstage fall away, and the second stage engines are firing, but you can't see a flame. And you can even see this with film from the ground. When the first stage detaches, you can see the glow from the second stage engines as they ignite, but there's no flame at all. So for the people who say we didn't go to the moon, because if you look at the lunar module taking off from the moon, there is no flame. So obviously this is in a studio and it's just being pulled up on wires. Well, you would say there has to be a flame if you don't actually know anything about rockets and hadn't bothered to do any research.
Yeah. No, so with the liquid hydrogen and liquid oxygen style rocket engine, am I right in saying that they're known as cryogenic engines? Is that right?
Yes, it's because the fuel is not room temperature. In order to get oxygen and hydrogen to liquefy, you have to cool them down a huge amount. Liquid oxygen, I think, is about minus 140 odd, and liquid hydrogen about minus 200 degrees. Now, that is so incredibly cold that obviously the tanks had to be incredibly well insulated. And there's another statistic from the Apollo days. If you were to put ice inside the Saturn V fuel tanks, they are so well insulated it could take 80 years before the ice melted. That is a major piece of technology in itself, and the engineering required for that. It takes a lot of know-how to get that right.
Yeah. Because you see yesterday when the Delta IV Heavy was on the launch pad, you could see that kind of mist coming off the top of all the three booster stages.
Yes. Well, when the rockets are fueled up, because there's usually some slight evaporation, and so that means that the fuel will be turning from liquid into gas. And when it does that, it expands. And you don't want to have too much expansion because there's a risk that you're going to burst the tank.
Yeah.
Well, obviously, they're made to be very strong to allow for that. But whilst the rocket is fully fueled and waiting on the pad, then there's valves to allow the escape of this gas, and then shortly before launch those valves will be closed and the pressure will deliberately be allowed to build up inside the fuel tanks, and part of that is to help force the fuel down to the fuel pumps. As on the Saturn V, the excess hydrogen that came off the upper stages was actually led to a nozzle where it was burnt. But the only time you could ever see that was on Apollo 17, because the launch took place at night and you could see the flame. On all of the other flights during the daytime, the flame was so pure that you couldn't see it.
Wow. So with the Saturn V, if the F1 engines on the first stage are being essentially paraffin fueled, what was the cooling mechanism of the F1 nozzles?
I believe that fuel itself was circulated around the nozzles.
So the
oxidizer on that was liquid oxygen.
Oh, so it's still okay. So the liquid oxygen is still the oxidizer. Okay, yeah, I get that.
One other thing to mention about rockets is the way of measuring their efficiency, and you want to know how much impulse a rocket engine can produce. And so it's measured as the impulse per unit of propellant, and the term is called specific impulse. And it's either measured as a speed, the exhaust velocity, or as a time in seconds. So an engine that gives a large specific impulse will be really what you're looking for. So the Saturn V F1 has those engines had a specific impulse of 304 seconds. The Space Shuttle solid motors had a specific impulse of 268 seconds, so they weren't as powerful. Whereas the Space Shuttle main engines, those three which did burn liquid oxygen and liquid hydrogen, had a specific impulse of 453 seconds, so about 25% more efficient than the Saturn V's first stage.
And those are the engines that I believe that are now going on to the SLS. Is that correct?
Yes, essentially it's a version of those, and we hope to see the thing flying before we all retire.
I've got to stop you there, Jerry, because I've got to go and pick up my son from Scouts. But thank you very much. Thanks very much for taking the time. I'll do a nice little edit of it.
That would be great.
Do you believe the frontiers of space are there to be explored? Are you the sort of person who looks up at the night sky and sees more than points of light? When you first heard the words, "That's one small step for a man, one giant leap for mankind," and watched images of the first man to set foot on another planetary body, did the hairs on the back of your neck stand on end? If the answer is yes to any of these questions, why not join the British Interplanetary Society, who have been striving to further mankind's quest into space since 1933. The British Interplanetary Society. From imagination to reality. BIS-space.com